All right, so November 25th, 2020. This says if the degree, sorry, we're looking at improper fraction. So far, all of the questions we have done so far have been proper fractions. So we looked at proper fraction with unrepeat linear factor. We looked at proper fraction with repeat linear factor. Then we looked at proper fraction with unrepeat quadratic factor. And then we looked at proper fraction with repeat quadratic factor. So after covering all of that, we're now ready to look at improper fraction. Now here's what this says. If the degree of the numerator is equal to or higher than that of the denominator, the expression is an improper fraction. We're to change the fraction to a mixed fraction and then separate into partial fractions. So the degree there that they're talking about is the highest power of x. If the highest power of x in the numerator is equal to or greater than the highest power of x in the denominator, the fraction is said to be an improper fraction. And before you could separate into partial fraction, you'd have to first change the fraction to a mixed fraction and then separate into partial fraction. So with example 11, I'm going to demonstrate how this is done. All right, so the first thing I'm going to show you is show you why in example 11, the fraction that we have is an improper fraction. So first of all, we have x cubed minus 1, and this is over x plus 1 into x squared plus 1. So the first thing I'm going to do is I'm going to expand the denominator. So we're going to get x cubed minus 1 in the numerator. At the bottom, we have x cubed. Then we have what? X plus x squared. So this is x squared plus x plus 1. Any problems with that? I don't think you should have any. Even if you don't do it exactly the way I do it, you should be able to expand that. All right, so now if you look carefully, you'll see that the highest power of x in the numerator is 3, and the highest power of x in the denominator is also 3. In a situation like this, what we said is that this is an improper fraction. If the highest power of x in the numerator is equal to or greater than the highest power of x in the denominator, the fraction is an improper fraction. Now, to convert this to a mixed number, what we're going to do is we're going to divide, much like how we have always convert an improper fraction to a mixed number, for example, like 9/7, you would say 7 goes into 9 one time and leaving a remainder of 2. So whatever is the remainder, you're going to put the remainder over the 7. The similar thing we're going to do. We're going to divide the numerator by the denominator, and whatever we get, the remainder, we're going to put it over the denominator. So let's divide. We're going to divide x cubed minus 1. We're going to divide it by x cubed plus x squared plus x plus 1.
Sir,
right. Go ahead.
Sir, how is it an improper fraction? Just out of curiosity, if I am supposed to just randomly choose a value of x and put it into either of those equations, the bottom equation would still be greater than the top one.
What I would say to you is this. This is the definition for a proper fraction or an improper fraction. The definition is this. If the highest power of x in the numerator and the denominator are the same, by definition, it is an improper fraction. Also, if the highest power of x in the numerator is greater than the highest power of x in the denominator, it is an improper fraction. That's the definition. So what I would say to you is work with the definition. If the highest power of x in the numerator and denominator are equal, it is improper. If the highest power of x in the numerator is greater than the highest power of x in the denominator, it is also an improper fraction. So there are two conditions under which the fraction is classified as an improper fraction. So what I would say to you, don't even so much worry about why it is or isn't. Just work with the definition. Let's divide. I'm going to start out by saying x cubed into x cubed. X cubed goes into x cubed one time. So then I'm going to multiply now. 1 times x cubed is s cubed. 1 times x squared is x squared. 1 times x is x. And 1 times 1 is 1. Then I'm going to subtract. When I subtract, this is supposed to be x cubed. When I subtract x cubed minus x cubed, that is 0. Then I have minus x squared. This should have been x squared. Then minus x. And then minus 1 gives me minus 2. So what this is saying to me is that x cubed minus 1 over x plus 1 into x squared plus 1 is the same as saying 1 and 1, and if you want, let's say plus minus x squared minus x minus 2 all over x plus 1 into x squared plus 1. That is what it is saying. So what you get after you divide and you subtract, this is the remainder. And so you're going to write back the 1 plus the remainder over whatever you're dividing by. So you can write this now as, this is 1 plus, sorry, minus. Let's choose minus. I'm going to factor out a minus. So this is minus, and the top is going to become x squared plus x plus 2, because I factored out the negative, over x plus 1 into x squared plus 1. Now it is x squared plus x plus 2 over x plus 1 into x squared plus 1 that I'm going to now separate into partial fraction. This is going to be a over x plus 1 plus bx plus c over x squared plus 1. I'm going to multiply the entire equation by the denominator on the left. I'm going to end with x squared plus x plus 2 is equal to a into x squared plus 1 plus bx plus c into x plus 1. I might say when x is equal to minus 1, when x is equal to minus 1. I think I was hoping to finish on this page. All right, let's see what we can do. When x is equal to minus 1, we're going to have minus 1 squared plus minus 1 plus 2, and this is equal to a minus 1 square plus 1, and everything on the right is going to go. All right. This becomes 2a. 2a is equal to, we have 1 minus 1 plus 2, 2. Divide both sides by 2, we get a is equal to 1. Now that I have a, I need b and c. All right. What else can I do? I can say when x is equal to 0, or I could look at the constants. I could equate constants. On the left, the constant is 2. On the right, the constants would be a plus c, but a is 1. So therefore, so this is equating constants. A is 1, so we have 2 is equal to 1 plus c. Therefore, c is equal to 2 minus 1, which is 1. We have a and c. What we need now is b. To get b, I could equate the x coefficient. So if I'm going to equate, if I expand this, it changes to blue. If I expand this, I'm going to get bx squared plus bx plus cx plus c. So the constant on the right, sorry, the x coefficient on the right would be b plus c. On the left, the x coefficient is 1. So b plus c is equal to 1, but c is 1. So b plus 1 is equal to 1. Therefore, b is equal to 1 minus 1, which is 0. So x squared plus x plus 2 over x plus 1 into x squared plus 1 is equal to a, which is 1 over x plus 1 plus c, because remember b is 0, so therefore bx would still be 0, and c is 1 over x squared plus 1. But it's not finished, because remember the entire thing was 1 minus x squared plus x plus 2 over x plus 1 into x squared plus 1. So the entire thing would be 1 minus, and we're going to have 1 over x plus 1 plus 1 over x squared plus 1. And therefore, we're going to have 1 minus 1 over x plus 1 minus 1 over x squared over x squared plus 1. All right, ladies, that would be the end of the question.